be where y equals 1. That'll be, let's say, right here. And it's on the xy plane, so it's this line right here. You agree with that? Are you okay with that? So then it asks for the line on the xz plane where z is 2. So if that's z is 2, it's going to be like right about here. Xz plane, so that's going to be like this. You agree with that? So what's the plane look like that goes through both of those lines? What does the plane look like? There it is. There's that piece of the plane. There's the plane. Do you see it? It extends in these directions, right? It extends in those directions. Now it's asking you to find the equation of a plane. We've done that using how many points? Can we just use any 3 points based on what we know now? No, we have to have 3 points. What's the relationship we need between the 3 points?
You have to have y and x.
Y and x. You have to have 2 points where the x is the same and 2 points where y is the same, right? So you make like a little triangle. So start with 2 points. What 2 points? If I kind of label 2 of them, what are 2 points on there that would be great to start with? Let's call it A and B here. Yeah, what's A? 0, 0, 2. What's B? 0, 1, 0. So then we have to pick a point that either share. So which x or y value do these share already? They have the same what? They have the same x value, right? So we need to pick a third point that has the same y value as either one. So we've already drawn all the points we need. We can pick any point we want on the blue line or the red line. So let's just pick a point, let's say right, I don't know, right here. What point could that be right there? How far forward do you want to go? What's a great number to use? 1. So x is 1. What's y? 1. It's because it's on the red line, right? And what's the z value? So what do we now have? We have a constant y. So what can you find now? You can find partial z with respect to x and partial z with respect to what? Y. Find me those two things right now. Find me, based on those 3 points, write them down. There's no trick. Partial z is -2. So you get -2 and 0. Do people agree with that? Yeah, that's great. So what was the equation? Can someone just rattle off what that general equation was? Someone rattle it off for me. What is it, Annie?
Z minus z naught equals m x minus x plus n y minus y naught.
Exactly. So we put these in, we get z minus z naught equals, oh, what's m? Oh, 0 times x minus x naught plus what? -2 times y minus y naught. And what's the only other thing we need to plug in? Any point we want, right? Let's plug in 1, 1, 0. Let's plug in this one right here. If we plug that in, what do you end up with? Z equals -2 y minus, yeah, so z is equal to -2y plus 2. So what's not present in there? But that should theoretically make sense, because here's the thing. It's the same line. Imagine you just connected these 2 points right here. You see that? Going forward and backward. Independent of the x value, it's always that segment. And if you extend it, it's always this. So if you took that line right there and scanned it forwards and backwards, what would you end up with? That plane.
Because the plane's parallel to the x-axis.
Not parallel to the x-axis. The plane is, the value of x and y is independent of x. It doesn't matter what x is.
It's actually like stretching in the same direction as the x.
You can say that. As you can, if you move parallel, if you move in the same direction as the x-axis, So if you move this thing this way and this way, what do you get? You get this plane. And my pretty picture now looks like not as good because I just did that. But do you understand what I'm trying to draw there?
But the plane will never intersect the x-axis.
Yes, the plane will never touch the x-axis. That is correct.
Okay.
The plane will never touch the x-axis. Yes. How you feel about this one? Pretty good? Pretty good?
Yeah.
You could kind of call this a planar cylinder. Yeah, what's up?
So at points,
This thing from the side, we're looking at it from this direction. So this is, we're going east. And what is this? Population density? So if we do that, let's just start at this point right here. What's that black represent? 0, right? So that's going to be like this x value, so it's 0 right there. And then it goes up a little bit, it goes up a little bit, it goes up pretty constant, right, to 0.5. So it looks like it's kind of going up, up, and up. That's these 3 points right there. And then what does it do? It goes to 2, but you see this distance right here? That's bigger, so it like flattens out a little bit, right? So it's something like this, it flattens out, right? And then what does it do? It goes down to 1.5, right? Stays there for a little bit. Or we can imply, we don't really know what happens between, but it's not going to go up or down too much. And then what happens? What happens right here? It goes pretty steep though, right? And then it kind of goes down to 0. Do you see what I mean by a rough sketch?
Yeah.
So they want you to do 2 of these cross sections like this and then 2 like this. Does that kind of make sense? So you're thinking about this in 3 dimensions and then looking at it from the side. Okay. On these is going to be complete the square. Why do you need to complete the square, Stephen?
Or you know nothing of what it's doing.
Yeah, you need to complete the square because you need to put it in something that these are going to look like circles or hyperbolic paraboloids. Some of these are circles and some of these are hyperbolic paraboloids. The ones where it's x plus or minus something plus y plus or minus squared is going to be a circle. What's the general form for a circle? Do you remember? X minus h squared plus y minus k squared equals like r squared, right? And what's the center of the circle? What happens if I change this to a minus sign? It's no longer a circle. What is it? Hyperbolic paraboloid, right? So you have to change these right here. What do you have to do to them? Complete the square. And then you just have to use analysis, like do investigative analysis. You look at things like, you see these values right here? Those are negative, right? Can either of these be negative? No. What? Oh, excuse me, there's a negative on the outside. So this one could be negative, but like that one can't be. So you can do it by process of elimination. So there's no one way to do it, but you look at it in terms of, okay, well, this is constant differences. This looks like it starts out further. You know, you're going to have to just do it piece by piece. Remember how you had to match slope fields to differential equations? Do you remember that, everybody? You did that by investigation. You don't try to do the whole thing. Pick like one curve and see, could this represent what this function is? Yes, no, no, move to the next one. Kind of makes sense? So when you complete the square, you're going to first look at which ones are positive and which ones are negative, and then you can figure out which ones are the hyperbolic paraboloids and which ones are the circles. So you match those two and get it down to 4. Just eliminate one by one. Eliminate one by one. Kind of makes sense? Right here, you would have an X shape like this. It would be an X. So those lines right there. And then in between, what do you see? You'll see the curves look like this. That's what the contours will look like. But the only difference is, what's the difference in contours here? The output values, see? -2, -1, and 2 and 1. So some of those go up, some of those go down. You have to figure that out by analysis. Okay.